This competition was led by DOB's in-house innovation committee and a special judging panel with both public and private sector stakeholders and chaired by the department. Here you'll see our list of judges for this competition. Daniel Avery from the Building Owners and Managers Association of New York, Gina Bokra, the DOB Chief Sustainability Officer, Sean Brennan from the Building and Construction Trades Council of Greater New York, Raymond DiDazio, American Council of Engineering Companies of New York, Anthony Fiore, New York City Department of Citywide Administrative Services, Jonathan Hernandez from the New York State Society of Professional Engineers, Robert Holub, DOB architect from the Code and Zoning Interpretation Group, Jill Rubecki, DOB executive engineer from Investigative Engineering Services, Shaji Joseph from the New York City Fire Department, John Lee, representing NYSERDA, Claire Mifflin, ThinkWoven AIA New York Committee on the Environment, Patrick O'Donnell, NYC EEC, Nick Petrakis, New York City Fire Department, Alan Price, Director of the Office of Technical Certification and Research here at DOB, Donald Ranchty, Building Trades Employers Association, myself, Zachary Steinberg, Real Estate Board of New York, Wendy Wan, Architect Code and Zoning Interpretation Group at DOB, and Stephen Zarinsky of the AIA New York. In addition, DOB participated with the New York City Economic Development Corporation's Urban Tech Initiative and the Urban Tech Hub at Company to help engage in clean tech and advanced manufacturing sectors in the Carbon Neutrality Innovation Challenge. Many, many thanks to the Tech Hub, and in particular, Robinson Hernandez and Anna for their outstanding collaboration to make this day a reality. In addition, I'd like to give an extra special thank you to the DOB staff whose efforts behind the scenes led us to these presentations today. Namely, Joe Soldiver, Danielle Delahanty, John Lee. And with that said, let's get started.
All right, everyone. We're going to turn over to our first presenter, Rachel Rosen from Wex Energy. Remember that you can just click that QA panel to the right of the screen if you want to ask her questions as we go. Rachel, I'm going to turn it over to you now.
Okay. You share that, allow us to share screen, please.
You should be able to now.
Great, thank you. I'm Rachel Rosen, CEO and co-founder of Wex Energy. I have nearly 30 years experience as a property manager, developer, and building owner. And I know what keeps my customers awake at night, probably some of you too. At the core of our sustainably designed, simple solution is a big impact: carbon reduction and energy savings powered by measurable financial results. Let me explain. Up to 50% of heating and cooling dissipates out the window, making windows one of the biggest sources of energy loss in multi-story buildings. Here in New York City, buildings account for 70% of the emissions. 2/3 of today's building stock will be in use in 2050 and beyond. Yet less than 4% of windows are replaced annually due to major disruption and high costs. Doing nothing has dominated the market. Wex Energy is changing that with a simple cost solution called Windowskin. Windowskin is not window film. I know it's hard to see, but that's the beauty of it. Windowskin is there delivering up to 75% of the insulation improvement of a new Energy Star window for just 10% of its cost. Tatum Engineering independently validated Windowskin's energy performance, showing a 12% reduction in natural usage on an already certified platinum building with Windowskins mounted on single pane windows with exterior storms. Windowskin is clear, featherweight plastic panel that creates an insulating air gap between your window and Windowskin. Our fitted panel snaps directly onto the inside window pane to easily install in just minutes. Training takes less than 30 minutes, no tools, no disruption, no construction. Windows open and close just as they did when Windowskins were installed. Unlike window replacements, Windowskins attach to the glass window pane, Building management needn't worry about disturbing underlying site conditions such as lead paint or asbestos. Windowskins are durable and long-lasting and manufactured in upstate New York from a 100% USA-based supply chain, and they're protected by a deep US and international patent portfolio. Until Windowskins soft launched last year, New York City building owners had few cost-effective options. Window replacements are costly, provide poor ROI, and the work is very disruptive to tenants. In New York City, windows are replaced about once every 100 years. Energy-efficient window treatments only work when window treatments are drawn closed. But if tenants can't see out the window, what's the likelihood the window treatments will remain closed, keeping your heating costs under control? Less costly are exterior storm windows and more recently, interior window retrofits, formerly known as interior storm windows. As many of you know, storm windows can be hard to use and often restrict window operability. Wux Energy competes directly with 5 other companies in the interior window retrofit market. Our competitors attach their products to the window frame, effectively rendering the window inoperable. David Ecker of Ecker Window in New York City says Windowskins are 100 times better than storm windows. Windowskins stand out from the competition by filling the market gap for pricing, window operability, and transparency. New York City is leading the way with the most aggressive carbon reduction law in the country, Local Law 97. For example, beginning in 2024, these New York City condo owners on 13th Street will pay penalties over $66,000 every year if they do nothing to reduce their building's carbon emissions. Their previous options were limited to replacing the windows for at least $750,000 or installing bulky, less effective window inserts for about $90,000. Now they can buy high-performing Windowskins for only $37,000. Windowskins Payback is 10 times faster than new windows and 4 times faster than the least expensive window insert. If you're this building's GC, how would you advise your clients? We can't solve climate change by only addressing market rate housing. That's why Wux Energy proposed Windowskins to New York City for this challenge. The time is right to bring the LMI community into the conversation now. Our customers are already reducing energy costs and carbon emissions in the LMI, multifamily housing, historic, university, and commercial markets. We've already sold Windowskins to 2 properties in the LMI sector. Wux Energy is on track to launch the low-profile Windowskin in Q1 21 and the Windowskin infiltration blocker in early 22. And we're working with a leading international window film company to introduce the solar control Windowskin by early 23. The solar control Windowskin is important to the New York City market because it cost-effectively addresses solar heat gain on upper floors of multi-story buildings. Smart windows wear Windowskins because installation is so quick and simple that tenants don't expect rent concessions. Windowskins do not impede emergency egress. Our base material meets IBC definitions for approved plastics. In fact, the plastic we use has been deployed in the glazing industry for years. And Windowskins retain their clarity for 20 to 50 years. Windowskins is a cost-effective solution for the LMI housing and market rate buildings. Whether they're responding to Local Law 97 or simply looking to reduce expenses, carbon footprint, or improve occupant comfort. And for those of you distributing installing LEDs, Windowskin is going to fill the gap in your energy efficiency toolkit. Wux Energy is in early discussions with NG to add Windowskins to their portfolio of energy efficiency measures. We're already working with New York City partners such as Ecker Window and Greenwich Energy Solutions, and we look forward to working with many of you in today's audience. Wux Energy has an experienced, tested team. I've managed property portfolios of up to 4 million square feet, and I've renovated historic, multifamily, and commercial office spaces. Ron Wexler, Wux Energy's founder and CTO, spent 22 years at Eastman Kodak bringing concepts from the lab to market. His inventions were incorporated into products with $2 billion in sales. Bomer Plastics, our manufacturing partner located near Syracuse, New York, has been in business over 70 years, serving Fortune 500 companies such as Amazon, Siemens, and Xerox. Bomer is ready to scale manufacturing to meet New York City needs. Wex Energy is ready to unlock New York City's pent-up demand for energy-efficient window retrofits. We're ready to scale Windowskin, an affordable window retrofit solution that is well-suited for the underserved LMI housing market. Windowskin can improve the energy performance and carbon emissions of New York City's existing buildings today and tomorrow. Imagine if every aging window in New York City was retrofitted with a Windowskin, carbon emissions would drop by 23 million tons over the next decade. The impact in New York City is equivalent to banning all vehicles from city streets for more than 1 day per week of the year in and year out. Wex Energy is ready to partner with New York City DOB, you the contractors and building owners, and our co-winners to help New York City achieve its GHG reduction goals now. Thank you for this opportunity. We'd like to congratulate our co-winners, and we're happy to take your questions.
So if anyone has any questions, please just click on that QA panel to the right of your screen, and you can ask Rachel questions now.
We're just going to stop our share. Stop share. You got to stop the share. Yeah.
All right. Thank you, Rachel. If anyone has any questions for Rachel later, you can feel free and ask them in that QA panel, and they will be passed along to her. Thank you so much for presenting for us today.
Thank you.
We're now going to move on to our second presenter, Hydro MX, Birkin Arakan, and Dan McCarty. So I'm going to pass over control of the screen to them now.
Thank you, everyone. Then I'll be sharing the screen.
Okay.
Everyone, thank you for joining. I'm presenting for Hydromix. I am the chairman of the CEO of the company. First of all, I'd like to congratulate all the winners. I believe each of them, they deserved it. They're all valuable innovations. And I believe buildings in New York are in dire need of innovative products. I also have to thank the Department of Building Sustainability team and the panel for choosing Hydromix and all the participants. I'm going to make this kind of short and as efficient as I can because our product is not as clear as the rest of the winners. Hydromix is a nanofluid. I wish I had time to explain what a nanofluid is. It's basically particles added to a base fluid. Particles are in the size of COVID-19, very, very small. So the first question usually pops up in our customers' end users' minds, what is a nanofluid and why Hydromix is the only commercially available nanofluid on the planet? And the only reason is toxicology. I cannot emphasize more how important this is in nano world. Unfortunately, FDA is pressing hard on nano companies to come up with their own materials and explain them how their materials are not toxic because nanoparticles change properties as you make them smaller and smaller. Hydromix cleared toxicology through NSF International's HT1 and HT2 registrations. I don't have time to get into this, but it's a USDA product approval and designed by FDA itself. So it's very, very important that any nano product will have this registration if it wants to make itself commercially available. Although Hydromix is a glycol-based product, both ethylene and propylene versions available, by the way. We do offer both versions throughout the world. We do have a big presence in India, as they started their marketing in 2014. Hydromix recently signed an exclusive distributor contract with Johnson Controls for Middle East and Africa markets. As you can imagine, both are pretty much hottest areas of the globe, and 95% of the applications over that are water-based. And yet, Hydromix has over 40 independent third-party verified major case studies, mostly in India, and all of them are versus water. Even though we're glycol-based, we're beating water. This is important to emphasize. Hydromix lowers HVAC-related carbon emissions by over 20%, and the payback period is never over 3 years. Hydromix guarantees it. We also have limited warranty against corrosion, calcification, and bacteria for 20 years. Our full liability insurance has yet to see a claim since its inception. When we engaged with the U.S. Green Building Council, this is a funny story on our part, we were told that there is not a product category for Hydromix. So in conjunction with the U.S. Green Building Council, we had to write one. So we did. And based on the product category we established, this rule specifically emphasizes our square foot or meter square area for carbon reduction. The NSF International Verified and Certified Comparable LCA, and hence EPD published. And both attest to our greenhouse reductions in both residential and commercial buildings, including data centers, versus water and glycol. And we recently received a rebate out of Midwest to prove the fact that our LCA and also measurement worked for both cases. Our LCA analysis is comparative, and from the attest letter, the panel that approved our LCA ran by a Harvard Sustainability Department, head of Harvard Sustainability Department, Thomas Gloria. So it was pretty strict. We do have a local manufacturing facility in New York, and we built the factory here to help the local economy and also to make it made in USA. So that's all I have to say. Now I'm turning over to our CEO, Michael Burgett.
Hello, and thank you for this opportunity. I have been an HVAC contractor in the tri-state area for over 36 years. Following our HBO case study, and after much investigation and experiments, my partners and I have decided to invest in HydroMX in 2015. HydroMX is a non-disruptive installation process on both new and retrofit applications. We've completed over 20 loops in the tri-state area, including an operational, decent-sized data center, approximately 15,000 square feet. We have performed many installations and several case studies in the tri-state area that were third-party verified. In one of our first case studies at HBO facility in Hauppauge, we achieved a 27% in efficiency and over a 90% increase in economizer hours compared to ethylene glycol. In our case study at Rexham Park, an SL Green facility, we achieved a minimum of 22% better efficiency compared to water. This was also verified by a third party, namely Yardi Systems. We have performed 12 installations in the Empire State Building, including chillers, boilers, and a runaround loop that now HydroMX has become the mandatory heat transfer fluid in all future closed loop hydronic installations at the Empire State Building. And now I'm turning it over to Dan McCarty, one of our partners in the Midwest.
Yes, thank you. Thanks, Mike. My name is Dan McCarty. I'm a partner at SBL Inc., and we are a manufacturer's rep and manufacturer located in Minnesota. We are also a Hydromix investor / board members. We have 2 board members, Jim LeBrot and myself. I just want to thank everybody for this opportunity. I was very excited to hear the news when it came through, and it's just an exciting opportunity for Hydromix. We're so excited about the product. Just a little background. 4 years ago, we were working with a phase change material, trying to come up with a thermal battery. And the good news is that the thermal battery changed phases, but it did not transfer heat very well. The idea was to do something similar to Kelmac and be able to store cooling or heating energy. During discussions with the products, with the experiment or the trial, I was talking to a professor from my engineering school. He brought up nanotechnology, and about a year later, through ASHRAE, we found out about Hydromix. We contacted them, and about another year after that, we bought into the company, moved it to the United States, along with the intellectual property. Initially, we were marketing a product based on payback periods, but the opportunities are even more endless with carbon neutrality in mind. One of the world's largest energy markets all around us is buildings, with more than $200 billion in annual energy costs and more than 30% lost in energy inefficiencies. In North America alone, energy efficiency accounts for more than $50 billion in lost profits. Buildings also generate up to 40% of all greenhouse gas emissions. Owners of large buildings, hospitals, schools, etc., generally circulate chilled or hot water to heat and cool their buildings. One can earmark capital to increase the efficiency of heating and cooling systems and improve building controls, new windows, etc. But until now, there has not been a product on the market to address the blood vessels of the building. By simply adding the technology to chilled water and hot water circulation systems, efficiency gains of an additional 20% can be achieved. An increase in efficiency equals a reduction in greenhouse gas emissions. And the great thing is the technology can be added while the building is in operation and the occupants never know that the change has been made. When complete, add data loggers and record the savings. As one of the largest manufacturers in the North American market, we know how disruptive it is to change out boilers, chillers, fans, etc. So why not go after the low-hanging fruit, which is the chilled and hot water system itself? In reality, Hydromix nanotechnology heat transfer fluid should be the first step to decrease a building's carbon footprint. It's inexpensive and easy to install and a true component of ESG. Thank you.
Thank you, everyone. We're open to questions right now.
As a reminder, if you'd like to ask a question, please just click on that QA panel to the right of the screen. It looks like we have a question from Kevin. Does Hydromix replace the existing heating and cooling fluids in a building?
Thank you for the question, Kevin. That's correct. We replace the fluid in its entirety. That's only change is required. That is only change that is needed, but nothing else. Thank you.
All right. If there are no other questions coming in right now, we will move over to our next speaker. We're moving over to Marshall Cox from Radiator Labs. Marshall, I'm going to hand you control of the screen right now.
Great, thank you. Okay. Share screen. Let's see if I can do this. Is that up? Just want to confirm you can see this.
Yes, we can all see your screen.
Excellent, thank you. All right. Thanks, everyone. Very excited to be here. Tell you about what we're working on. Obviously, congratulations to everybody who won this competition. We're very happy to be among them. So my name is Marshall Cox. I'm the founder and CEO of Radiator Labs. We're developing an energy management platform for steam-heated buildings. I got my PhD at Columbia University back in 2013, and my PhD had nothing to do with STEAM at all, but I lived in this hellhole apartment up in near Columbia, and was basically miserable. So miserable that I built this first system on my radiator to try to control the dramatic temperature swings in my apartment. We started talking to Columbia facilities, tried it out in a couple of their buildings. We ultimately competed in and won the MIT Clean Energy Prize in 2012. That launched the company. We've been working on this system and developing it, refining it ever since. And I'll tell you about a few of the big milestones as part of that journey. So just for background, I think most people watching are probably familiar with STEAM. It's a 19th century technology. About 70 to 80% of the buildings in New York City are steam heated. And I think it's a pretty bad rap. People who live in New York City are generally miserably overheated in the winter, et cetera. But steam isn't really a bad technology in and of itself. Back when these buildings were first built, they were really well balanced, but things changed over the past decades and even century. And the biggest change we underwent was that most people, we developed double pane insulating glass and pretty much replaced all of our windows, or the vast majority of our windows, to that higher efficiency technology. And if you have rooms with different numbers of windows, you've dramatically changed how much energy those rooms need. And it's not the same amount of change per those rooms. So you have rooms in the building that need more energy, rooms that need less. You have a boiler that is either on or off, and you have to cater to those colder spaces to get them to minimum temperatures. And when you've done that, the majority of the buildings have been vastly overheated. People open windows, et cetera. Everyone knows that story. So it's a distribution problem that that these buildings have, and it's not a very simple thing to fix. It's not something you can really fix with a plumbing solution effectively. And so what Radiator Labs has done is we've developed a smart radiator enclosure. It's an insulating enclosure that we install on top of these radiators. There's a thermostatically controlled fan in each system. Those systems measure the room temperature, measure the radiator temperature when the room is below set point, and I'll talk about how we grant temperature control with, in a few slides. So when the room is colder than set point, our fan turns on, pushes heat out into the room, that room heats up, and when it hits set point, the fan turns off, and this is kind of where the magic happens with our technology. So then the fan is off, there's no path for hot air to convect out of our enclosure. So the air around the radiator heats up and approaches steam temperature. And when a radiator is inside an environment at steam temperature, the condensation rate of the steam plummets and approaches zero. It's as if we closed the valve to the radiator, but we don't have to have any contact with the plumbing. We don't have any of the drawbacks of a plumbing solution. The technology then so we eliminate overheating in those hot rooms. We get steam more efficiently to cold rooms, and the efficiency gain in the building is dramatic as a result, and the comfort improvements are dramatic as a result. The technology is composed of three primary parts. There's those enclosures. Each enclosure has a wireless radio that communicates the data on that room in real time to the cloud, where our system learns how the building heats up and cools down. We control the boiler in the building based on that data, so we can maximize efficiencies. And then once all that data is digital, we can connect it to things like your cell phone or an app and individual user spaces that lets people control their temperature, often for the first time in the history of the building stock. So full programmatic control, you can do night setback, et cetera. The same thing you can do with an S thermostat, you can do with our technology. I want to talk for a second about the comfort improvements because they are dramatic. This graph is a little bit complicated, but it's essentially on the left a building before our retrofit and after a building with our retrofit. Each column is an hour of time between 6 a.m. and 11 p.m. And each apartment, each room is a slice here, and the color of that slice is basically the average room temperature over that hour. So you can see on the left here, this building had a lot of what we call sauna apartments over 82, a lot of frigid apartments, and then all in between. This is kind of the temperature distribution you see in a lot of steam buildings. A post-retrofit, on a day that is the same temperature outside, you can see the dramatic improvements of the Radiator Lab system. So again, eliminating those overheated apartments, getting steam more efficiently to those frigid apartments, so we eliminate frigid and overheated apartments, and then dramatically increasing the number of apartments that are at the ideal temperature set points. This is what we see in almost all of our deployments, pretty much all of them. The number improvements are impressive as well. We saved 25.5% on average. This is all through third-party verification, which I'll talk about in a second. We reduced maintenance calls by about 85%. Part of our analytics platform detects problems in real time in these buildings, in both the distribution system as well as the envelope, and we communicate that information, again, in real time to maintenance team and or whoever is the right contact to communicate that information. And we have 95% fewer heating complaints because we do eliminate those dramatic temperature swings and extremes in the hot and cold spectrum. The 25.5% savings I mentioned is a result from a NYSERDA study published in 2018. So they studied 7 of our buildings over 5 years, and over that 5-year span, we saved 25% on average. The highest savings we found was about 48%. The lowest savings was 15%. That data allowed us to develop an equation that we can use to predict how much we'll save in a building just by going through some of their heating bills. And that's obviously the first step we take with potential customers. And based on this data, the New York Technical Resource Manual entered us into that manual in late 2019 and includes that equation, which basically highlights as by far the best efficiency gain technology for this building stock. I just want to talk about one of those buildings in the NYSERDA study, this building here in Clinton Hill. This building, post-retrofit, this building saved the least amount of all the buildings we deployed. It saved 15.5%. And post-retrofit, it is compliant with Local Law 97 2030 goals. So this is right now the most, if not one of the most, if not the most efficient single pipe buildings in all of New York as a result of our technology. So even in buildings that are essentially at the cutting edge of heating efficiency, we can still save 15% plus. And then of course, those buildings who are less efficient, we save upwards of 40, 50%. This is our last slide. I just want to talk about a few of our customers. Obviously, we're in a lot of multifamily buildings. We're in a lot of commercial municipal buildings. We have a deployment with the Department of Education happening this fall. We're in 2 New York NYPD precincts, expanding to 4 more. What we like to do with larger portfolios is, and this is all for free. We do this just as a consultative process. We ask for as much fuel data as people can share for their entire portfolio. It doesn't matter how many buildings. We've done this for LaFrac. And we calculate the building use intensity, how much fuel it takes to heat that building per square foot. And then we calculate how much we'll save and how much it'll cost. And we basically come back to customers, say, these are all your buildings. This is how long our payback will be. And if we want to move forward, these are the ones that we should move forward in because it makes the most sense. It's the lowest hanging fruit. We can work with customers with an upfront sales model, and we also have a finance model where we guarantee, where there's no upfront costs and we guarantee savings over time. So we're very happy to be here again, very happy to get questions from you. And please reach out at this email address if you have any questions. We'd obviously love to talk to you and learn more about your buildings. Thank you.
Thank you, Marshall. We'll hang for a second and see if anyone asks any questions in the QA panel.
There are usually a lot of questions.
So we just got a question in. Do you know when this measure will be introduced into New York State TRM?
There's an echo somewhere, but I think I heard the question being, do we know when this will be in the TRM? And if that is the question, it is already in the TRM. Did I answer that sufficiently?
We have another question here. What is the typical payback period?
So that's a great question, and the honest answer is it's a pretty wide range. It depends on, since our efficiency gains depend on the building efficiency. So if the building is very efficient, we'll save less, and the payback will be longer. And if the building is inefficient, we'll save more, and the payback will be shorter. And then within that, if you consume district steam, for example, which is very expensive, the payback will be very fast. And if you consume natural gas around an interruptible rate and you pay very little per therm, the payback will be longer. So we typically see anywhere from, on the fastest side, 1 to 2 years. On the longer side, 6, 7, maybe 8 years. But again, that is the upfront model. The service model is typically, it's going to be a 0-year payback for everybody. Every building that qualifies, and most buildings qualify.
And so we have a question about, is this user-friendly from the tenant perspective, such as for those not as tech-savvy, such as an example given is elderly?
Absolutely. So in its simplest sense, so in every use case we have, we either give control to people in the spaces or we don't, depending on what the customer wants. So we're in housing authorities where there's no control given. Columbia University, for some reason, didn't want control when we first started working with them. And we can basically set a schedule that it just operates on. For those who do get control, there is an app that it's, you just say the time and the scale. So yeah, you have to be a little technically savvy to do that. But we also have a process for typically the elderly in our buildings where if they want something done, they can just email us and we'll implement that schedule. So we're very receptive to people who may not have the ability to integrate or work fancy equipment. And just as a last, we also have an optional button thing, so you can just press up or down, and there's kind of a scale that goes on the unit itself. So you can have controls on unit if it's desired.
All right, it doesn't appear that we have any more questions at this time. However, if anyone has more questions, they can ask, and we will send them along to Marshall following his presentation.
Great, thank you so much.
Thank you for joining us. We are now going to move to our last presenter, Zinc 8, Ron McDonald, Mark Baggio, and Simon Fan. Simon, I'm going to turn control of the screen over to you right now.
Thanks. Are you able to see the screen?
Yeah, I can see the screen. Can everybody hear us well? Okay. So hello, everybody. Good afternoon, early evening. I'm Ron McDonald, and I'm President and CEO of Zinc 8 Energy Solutions. We're so pleased to be announced as the winner in the New York City Department of Buildings Innovation Challenge. And I've listened really carefully to all of my co-winners, and I'm very, very pleased to be in such an esteemed group. What a great group of innovators. And hopefully we'll all have an impact on a brighter, greener future. And we really look forward to working with them all to that end. So slide 2, Simon. So in the last presentation that we didn't have a lot of time. We had like 5 minutes, and I think a few people had sent me some emails saying, like, where did you guys come from? Because a lot of people, I've been in the battery space for a long time, maybe 15 years, and zinc air batteries have been talked about for a very long time. Well, we started way back in 1997 out of Carlsbad, California. A group of investors got together to scale up zinc air batteries. They weren't that successful because the market really didn't exist for long duration storage at the time. So in 2004, it was further developed behind the curtain when their IP was picked up by Giant Tech Resources, and they gave us the name Zinc Energy Solutions. I think they took us on at the time. I wasn't here because they thought if this technology is successful, it would be a brand new market for zinc. Didn't turn out to be that, and I'll tell you why later. In 2013, we started a new R&D facility, and in 2019, the company went public on the Canadian Stock Exchange. So last July was our first real breakout into the public. So most of the work that was done by our high-tech team, and we had as many as 40 or 50 scientists and engineers working here, was done behind the curtain. So when we did become public, it became very clear that people started to look at this as a new technology that might have a market. We rebranded in 2020 as Zinc 8 Energy Solutions, and in 2020 as well, we established Zinc 8 Energy Solutions US. So today we've got 20 US patents. We got 4 pending. We got, I think, 3, Simon, that are being written. We spent about 56 million, maybe 60 million since 2000 US dollars since 2002, and we've got 3 demo projects announced that we're currently developing. And slide 3, we can go straight into that. So New York City and New York State to date have been core to our current and to our future success for sure. And we're delighted this February to have been selected as the winner of the New York Power Authority Innovation Challenge to develop long duration 100 kilowatt, 1 megawatt hour storage for their zinc air battery system. And shortly thereafter, we were also selected by NYSERDA, together with our partner Digital Energy of New York, to deploy 100 kilowatt, 1.5 megawatt hour zinc air battery at a behind the meter location to be announced shortly. But I will tell you, it's in Brooklyn. And we were honored this year as well to have been accepted in New York's Acre Incubator at the Tandem School of Business as one of their member companies. And I think a few of the other winners here today have gone through that path, and it's a good path to go through. And Zinc 8 Energy, as I mentioned earlier, is now a US registered corporation. And the company's business plan would have a full commercial production in 2023 at about 40 megawatts, which is quite large for initial, and that will take place in upstate New York. Stay tuned for when we announce that. Slide 4. So slide 4, we talk about our approach here to long duration, low cost energy storage, and our presentation addresses the topics of energy storage, distributed generation, really important, building system management and operations. We're a very flexible system. We provide a customizable component-based tech that has decoupled energy and power, which gives us our cost advantage in the global markets. And Simon will speak to that. The other real big thing here, we've got no exotic, no toxic, or ethically or politically challenged materials or supply chains that we've got to deal with. Our materials can be entirely sourced and produced and manufactured in the USA, which is major, particularly as governments are constantly looking at supply chain risk. The coupling of energy and power gives us the lowest cost battery energy storage system available. Quite simply, the longer the duration, the lower the install cost per kilowatt. So the bigger you grow, the cheaper the system comes per kilowatt hour stored. Our solution is durable. We have no battery fade. Everybody knows some other batteries that over time, your computer battery, that the more times you charge it, the less efficient it becomes. We have a 20-year battery life. We're robust, we're low cost, and for greater integration, we make for a greater integration of renewables to the grid. So our battery is really safe, and I raise this a lot of times. I usually say it's really, really safe. We have no thermal runaway, so we have no fire risk. We have no toxicity, meaning we can install this in a factory, a college, a hospital with no special containment buildings or thermal suppression systems required. And we are sustainable and designed for mass production, and we support well-paying green jobs in New York. And importantly, we don't consume any of our materials. This is amazing. So the zinc gate particles that we generate, and Simon's going to go through this in a minute, are really a catalyst, and they are reused over and over again for the life of the battery. So that being said, I'm going to pass it over to Simon Fan, who is our Chief Technology Officer, and he's going to talk a little bit deeper dive in the technology. So Simon, it's over to you for the next couple of slides. You're muted, Simon.
Yeah, thank you, Ron. My name is Dr. Simon Fan. Please allow me to proudly present to you the modular scalable energy storage product that we have developed over the years. The zinc gate energy storage consists of 3 main components: the zinc regenerator, the storage tank, and the fuel cell stack. The zinc regenerator is an electrical chemical device which enables the end user to mix zinc particles, or what we call energy particles, on site by charging the system with electricity from any power source. The particles that we generated will then be autonomously transported to the storage tank for on-demand use. When electricity is needed, these particles will be delivered to the fuel cell stack, where they will be dissolved in the electrolyte and combined with oxygen to electrochemically produce electricity. At Syngate, our core competency lies in the creation of such particles, as well as their transportation between each of the subsystems and the management of these particles in our fuel cell to produce electricity. So storing zinc particles in a storage tank away from our zinc regenerator allows the true decoupling of energy and power. What that means? Well, the maximum energy capacity of most of other energy storage systems is a function of electrode area, which is both difficult and costly to scale. For example, to increase the energy capacity or duration, you will have to buy more battery pack, which means you are not only buying the energy, but also buying the power that you may not need. On the other hand, Zinc 8's maximum energy capacity is only limited by the tank and its size, one of the most inexpensive components of the system. To increase the duration or energy capacity of the system, you will only need a bigger tank for housing the electrolyte and sink, which are abundant and inexpensive. So what we enable the customer is to participate in surflow value stacking program, and also shaving the peak that they may have encountered during the day. Because of the product's low cost, long duration aspect, now it is finally economical and possible for the end user to take advantage of the time of use rates by charging the system overnight on weekdays and over the weekend, and by discharging it during the day on weekdays. In doing so, the customer can now significantly reduce their electricity bill. Also, the long duration aspect of our storage system would provide the energy resiliency to the customer. Even in unpredictable weather, the system will provide sufficient energy to support the regular economic activity. So this is the summary of what our tech can offer. Now I pass the time back to Ron.
Okay, Simon, thank you very much. So what Simon has talked about is how we make the economics of renewables, be it rooftop solar or any other source of renewables, how we make the economics better. There's a lot of wind turbines out there all over the United States. Those wind turbines are notoriously inefficient because 20% of 25% of the electrons have got to support the whole installation. In short, our type of battery system can monetize more electrons, and if you're dealing with rooftop solar, make those systems more economic. I just want to talk about this very, very briefly, and it is the reason that we're really getting a lot of attention. So this talks about the comparison of different technologies for a 100 kilowatt battery system and cost per kilowatt hour stored. So if you see this, you see the lithium ion, they own the waterfront under 4 hours. They can perform well economically, 6 hours most likely. Then their economics flatten because of the reason that Simon talked about, because you have to get your power and your energy. It's a 1-to-1 ratio. Vanadium redox batteries, great technology, been involved with it forever. The electrolyte can be very expensive, up to 60% of the cost, and they just cannot, they will find it eventually, I'm confident, but currently that's the range of costs that we could find. For our system, we're $250 per kilowatt hour installed at 8 hours. When you get to 20 hours, we go down to 127. When you get to 30 hours, we're down to 100. When you get to 40 hours, 86. I think at 100, I think we're down at $60. So this opened up a significant market that currently didn't exist with utilities, but also for any installation that needs long duration storage. Next slide. I'm going to go through this very quickly in case some people out there are also investors and are saying, well, where's the economics that would justify the development of this industry? These are all referenced down at the bottom of the screen. You probably can't see them. Renewable energy baseload globally 2030, estimated $42 billion market. That's to support remote microgrids. Peak demand management and backup power, which Simon has talked about. And this is just in the US, it's estimated to $350 billion. And T&D upgrades, deferral, it's estimated that between now and 2050 globally, because of the rapid escalation of electrification, in large measure driven by from combustion engines over to electric vehicles, is about $14 trillion. And we think that there's about 1.4 trillion of that could be supported by our type of storage. So next slide. Okay, so this is kind of our final slide, and we're talking about a carbon neutral New York City. That's why we're all here. So Simon explained earlier, our technology can address high demand charge by peak shifting, and I think a lot of people on this audience would know what we're talking about and take advantage of time of use arbitrage, but you can do it economically. This provides opportunity for our system to be retrofitted into existing buildings or to be built into new projects to both manage high energy costs as well as unleashing opportunities for building generation of its own renewable energy resource. And again, as I previously said, without costly thermal suppression or special containment. So these same attributes allow for the development of grid-level distributed energy systems, providing some of the risks of power disruption from our increasingly unpredicted and volatile weather. Superstorm Sandy. You guys know it all. So in conclusion, we believe that we, Zinc 8, can play a significant role in helping transition to high carbon, high GHG energy mix to a renewable and carbon neutral future for New York. Our tech supports and enhances the economics of renewables, such as solar and wind on the grid, and lessens the reliance of owners of currently struggling transmission and distribution systems in New York City and New York State. So in conclusion, Zinc 8 Energy Solutions, we're committed to partner to a green, sustainable New York City, and thank you very much for this opportunity.
Thank you very much for sharing this with us today. We have a question from the audience. They're asking, is it AC or DC voltage, three-phase? No.
Simon?
Well, our system is a DC system, but we will have to work with developer or electrical contractor to change it to AC. So that will be an AC-DC inverter.
Does anyone have any other questions for Zinc 8 today? We'll give it a minute if you want to type in a question there on that QA panel.
Okay.
Okay, great. I'll turn it back over to Gus.
Great. Thank you, Seth. Thank you all. Those are some fascinating efforts to improve the sustainability of our city's buildings. It was a real pleasure to work on this effort and to see firsthand how our city's innovators are bringing their creativity to bear on one of the most pressing problems of our time. I hope you all enjoyed the presentations as much as we at DOB did. When it comes to fighting climate change, we're all in this together. Thank you to our winners for submitting their ideas for making our city more sustainable for future generations. And to the audience, thank you once again for joining us. I would like to point out that this is day 2 of our Build Safe, Live Safe Digital 2020 Safety and Innovation and Sustainability Conference. We have events scheduled throughout the week, including the results of yet another competition, the Hack the Building Code competition, which will be presented this Friday, where we'll announce those winners as well. You can find out more information about that on the department's website at nyc.gov/buildings.
All right. Thank you very much, everyone. Have a good rest of your day.